Right. Okay, so the obligatory first slide. Who the hell am I to tell you about data science? Well, I'm a retired teacher, recently retired. I taught maths and computer science. I now do a bit of tutoring after school and I mark exams. I learnt data science as a lockdown project. Um, I had a few interviews. I thought that might be my escape out of the classroom, but didn't quite land that job. So I'm not the person to give a workshop on how to get your first data science job. I'm very happily retired. So not gloating, but there is light at the end of the tunnel, and it's wonderful. And the highlight of my week, most important thing of all, I'm on the organising team of Codebar Brighton. Lovely community, as you all know. So, what are we going to be doing? The workshop is in two halves. I've got a bit of theory first because I'm a teacher. I want to explain what data science is, and then give an example of one type of data science. So a bit of theory first on some slides, and then the second half we'll move over to a website where we'll have a look at some live coding. And don't worry, you're not going to be typing code and spelling things wrong. I've been in so many workshops like that myself where I type something wrong and I get behind and I panic and so I've tried really hard to make it as simple as possible. So it's a lovely day. You can just sit back and relax and soak it up. I'll ask a few questions, but there's no pressure. It's all very low level. And I know some people have maths anxiety. There's no difficult maths in this. If you've got GCSE maths, that's all you need to understand today. If you go on to study data science in more depth, there is a bit more in-depth maths and coding skills get a bit more demanding, but it's not difficult. So hopefully everyone, if you've got basic maths and basic Python, if you learnt them at school, that should be enough to follow what we're doing today. So the example we're going to look at, as you can see from the photo, I love cycling, so I found a data set about cycling. We're going to predict the level of demand for rental bikes in London based on a few factors. Anyway, that's the second half. So let's start the theory. So the first bit is the slides I've taken from a sixth form lesson I wrote on what's the difference between data analytics, which most people have an idea what data analytics is, and comparing it with data science, because they're both very important and they're both very different. So hopefully I'll explain both of them and you'll see the difference. So a little bit of history. I'll whiz through this. It's a bit like a sixth form lesson, but it just sets the scene. So 1850s is kind of the start of data analytics. Florence Nightingale, absolute data pioneer, revolutionized healthcare by applying data techniques. And she invented something called the coxcomb diagram. And I guess if you take the right psychedelics, it might possibly look like that flappy bit on a rooster's head. Anyway, data pioneer. Fast forward a bit to the 1950s, birth of electronic computers. Alan Turing had just built a machine to crack the code in the war and develop those ideas into the first electronic computer. And then in the 50s, everyone started jumping on the bandwagon and seeing the possibility. And Lions Tea Room, I don't know what this would be the equivalent of, but a British tea room was the first developed the world's first business computer. There's a wonderful film. We haven't got time to watch it. There's several versions online. I'll share the slide deck and there's a link to the film. It's only a few minutes long. Do watch it. It's amazing. I'd never heard about that. So fast forward again to the 1980s is kind of where it started. We started hearing the phrase data warehousing. We still hear that. Um, for the first time ever, large data sets could be stored and analyzed in one place. There was enough memory to store everything. So I don't know if you could analyze all of the every household's electricity bill for the last 5 years or something. There was enough storage capacity and processing power to do that in one place, and that was kind of the birth of what we think of as data analytics. Back then, it was known as business intelligence. Um, just a bit of context. I haven't looked this up, but I would imagine a 1980 data warehouse probably had the capacity of your mobile phone these days, but it was a revolution. So, data analytics definition, examining and interpreting existing data, and the key there is existing data. We'll come back to that. Drawing useful conclusions, and what's the point, to answer business questions. And it's a bit like being a data detective. So you go onto the scene of a crime and you look round and you see all the evidence and you've got to spot what's important. So you're sifting through all the data, looking for clues to solve your business problem. Right, that's kind of what most people understand of by data analytics. Data science is a bit different. So people have been working with big data since the 90s, when those data warehouses started expanding. And it was called all sorts of things back then: data processing, business intelligence, all sorts of things. And then around 2010, the technology advanced far enough that it started to coalesce into what we now call data science. And the term data science was born around then. And there's still no universally accepted single definition, but lots of people have had a good go at describing it. So we'll have a look at a few of those. 2010 turning point, Drew Conway, everyone loves a Venn diagram. Drew Conway said it was the intersection of what he called maths and stats knowledge, substantive expertise, which just means subject knowledge. So, do you understand what the data means? And hacking skills, he called it. It's kind of coding skills, but also the approach of hacking away at a problem. So those intersections are quite interesting. This bit was from, I'd say, from an A-level lesson. So we're not going to think, pair, and share. I couldn't be bothered to change the slide, but maybe in the chat, a couple of things for you to think about. According to that Venn diagram, subject knowledge isn't necessary for building machine learning models. So hopefully you can see, yes, you can see my pointer. I can see it on my laptop. So the machine learning here, it's a combination of hacking skills and maths, but no subject knowledge. Any thoughts about that? Oh, and I haven't got the chat up on my laptop. I've got two screens and a laptop, and hopefully I can keep up with that. Right. So, any thoughts on that? Do we need subject knowledge to build a machine learning model? Give you a moment to finish typing, but doesn't matter if no one has a thought on that. Right, so I would say that's right. If you give me a data set in a foreign language I don't speak, if it's got numbers, it's data. I can write a machine learning model. Oh, getting some answers, fantastic. Um, Domain knowledge is necessary. I'll come back to that with a caveat. Yes, I agree. But just for machine learning, I don't need to know what the data means. I can write a bad machine learning model. That's the point here. Data science is when you introduce the understanding of what the data actually means. That's subject expertise. Um, Subject can be described in some formulas and whatnot, then yes, it is required. Um, know what independent variables to select. Um, right. What you're all thinking about intuitively and kind of correctly is data science. You do need to understand the data to be a good data scientist. Um, if you don't understand the data, and I'm sure there are data scientists out there who don't really understand the data they're looking at and working with, that's just machine learning, uninformed. So let's have a look at one of the other intersections. So the danger zone here. Wrong screen. So the intersection of someone with subject knowledge, so they know about I've got some data on, I don't know, football scores or whatever it is. I know nothing about football, but lots of people do. Where's my pointer gone? So if I think, I've got a few coding skills, I can do something with my knowledge of football scores. That's a danger zone. Do we need um, do we need to understand the maths and stats, or it's like, well, today I suppose hacking skills would include chat gpt. Oh yeah, I don't even need personal hacking skills. Chat gpt can do it for me. I know about football, so I can be a data scientist. Well, actually no. um, there's a lot you need to know about the results you get, how to interpret them. And there's the famous lies, damn lies, and statistics. Um, if it's used wisely and neutrally, it can provide a reality check. So, which average is meaningful? You can, yeah, thank you, G. Context, absolutely, context matters. And understanding the maths and being able to apply the right statistical measures. If you can't do that, it is a danger zone, I would argue. Um, and the last one, traditional research over here doesn't involve hacking skills. So it's just the overlap of subject knowledge and maths and stats. Do we agree with that? Traditional research. Just wait a minute for any comments. I would say 50 years ago, hardly anyone wrote code. So historically, traditionally, nobody wrote code. So all research was without coding. And although data science has become an important part of research in many fields, there are still some fields that lend themselves to research without coding. So you don't have to have the coding skills. You can still do traditional research, and that's not data science. Traditional research plus coding, that is a form of data science. So, as I say, everyone loves a Venn diagram. Let's have a look at somebody else's description, not definition, description of what data science is. So again, in 2010, there was a framework or a process developed, OSEMN, and they were American, I believe, and apparently it sounds like awesome, awesome. So that looks quite familiar to modern data scientists. You obtain the data, you scrub it, get it into shape, ready and suitable for processing. You explore it, you get a feel for where the correlation is, you build a model, you train a model, and then you interpret the results. So you apply statistics at the end. And then the last description we're going to look at, and again, there's a link behind the screenshot there. We won't watch the video live, you can watch it later. Cassie Kozakov was Google's first chief decision scientist. When I was on Twitter, before it went to the dark side, I used to follow her, and she's just got the amazing ability of just cutting through all the crap and coming out with an amazing nugget of wisdom. So not very helpful, but great soundbite. She said data science is the discipline of making data useful. So what does that mean? It's a great soundbite, but she also said it was the intersection of analytics, and we saw in the awesome model, we do use analytics. That is part of data science. We need to analyze the data set and get a feel for it, get inspiration. Machine learning or AI, that makes the recipe, the formula to make the predictions, and statistics for making wise decisions. So I think that's probably too much information. I'll leave it in the slide deck. That's from the A-level lesson, as I said. But it boils down to, you can read that later, it boils down to data analytics is descriptive and data science is fundamentally predictive. That's the main difference. So quick example, and then we'll move on. So a hospital might use data analytics. They might compare the outcomes of surgery. So men and women, if there was a different survival rate for an operation, if the differences are statistically significant. So again, we're bringing in some statistics at the end for a reality check. If there's a significant difference, they investigate possible causes. So why are all the men dying, or whatever it is? Is there a medical reason? And data science, a hospital might use data science to predict things like recovery times. If you're managing a hospital, trying to predict how many beds are going to be needed, you need to be able to predict recovery times and how many of your patients going through the operation are going to have complications after surgery. And you make those predictions, as we'll see soon, based on factors, in this case, like age, lifestyle, conditions that you have already, things like that. So data science is predictive and data analytics is descriptive. Both important. I'm absolutely not saying data science is more important, but actually the market pays more. So if you if you want to make a bit more money, data science does still pay a bit more. Right, we're doing well. It's 12:30. There are lots and lots of types of machine learning models. The simplest one we can look at that you will all be able to relate to is linear regression. And that sounds like, oh, that's a mathematical term. I don't know that. I've not heard it. It's going to be complicated. You have done it before at school. They just don't call it that. Excuse me. So I did a talk, a lightning talk, what is data science, at Brighton Data Forum a few years ago. I made up a data set based on, I'd been to 4 Python conferences a few years ago, and I thought, oh, let's make up a fun data set. There's only 4 rows, 4 records. So we'll see if we can make a prediction. So I went to a conference in Poland, Paris, London, and Dublin. I like to tie it in with a bit of a holiday. And the data set I came up with, well, I got some data about, objectively, about the actual conference. Though that, excuse me a moment. So it's 4 conferences, how far away they were, the date, and then I split the date. We'll come back to this idea of splitting a complex field. I split the date into the year, month, and day, how long it lasted, how many people were there, how much it cost. And then for a bit of fun, I made up some ratings. So how friendly they were. I'm a vegan. Back in the day, it was quite difficult to get vegan catering at a conference. How inclusive it felt, quality of swag, quality of the talks, the venue, and then an overall average. They're all made up. It doesn't mean anything really. And there wasn't a codebar Python festival. Everything would have been 5-star, of course. So if you notice, well, actually, any comments about in the bottom half, my ratings? Any observations? What stands out to you about those ratings? There's 4 conferences and 1, 2, 3, 4, 6, and then I took an average. Yeah, thank you. Missing data. Yeah, so I'm not lying. I did go to Paris for a conference, .py, and then I was unable to. I'm just reading the chat. You're being data detectives here. That's brilliant. All right, Christy, you don't need to know the subject. That's the whole point. There's no pressure on you at all. It's just as a non-specialist, what stands out. So there's missing data. Has it gone? Yeah, so Paris, I was unable to produce ratings. Any detectives among you? I'll be very impressed, but I'll give you a moment to have a look. Actually, I'll draw your attention. I'll give you a clue. If you look at the date, what was happening on the 2nd of March 2020 when I went to Paris? I did go to Paris. COVID lockdown, yes, yes. So big news story at the time. I thought, oh, should I be traveling? I've heard that there's this horrible new virus abroad. It's not really hit the UK yet. Is it safe to travel? Oh, I think it's safe. They haven't told me not to go. So I did make it all the way to Paris. I had a lovely weekend with some friends. And then over the weekend, they cancelled the Monday conference. So I did go to Paris, but the conference was cancelled. So good detective work there, some of you. Right, got a comment from Send. Data type in the overall column is not the same type. It is actually, it's a calculated, that you can probably spot from the hash div 0. That was just copied and pasted from Excel. So it's just the average. It calculated the mean. So if it's a whole number, it doesn't put 0.0. Python would put, or the notebook we're going to use later, when it calculated the average, it would probably put 4.0. And then hash div 0, that's error, can't divide by 0, or no, what are we dividing by? Anyway, there was an error. Oh yeah, because I put the dash to show there was no data. So it tried to count the number of values, and there were zero values, so it couldn't divide by zero. But good detective work there. Anyway, as I say, I presented this at Brighton Data Forum. Bit of a joke. I said, "Oh, I'd love to know what I missed in Paris." There was one really good speaker I wanted to hear, and I'll never know how good it would have been. Except with the magical power of data science, let's find out. Um, so I used a machine learning model to work out what the ratings would have been. And obviously, the joke is there are only 3 conferences to base that prediction on. So it's ridiculous to make a prediction based on a small data set like that. But I did it anyway, and I got a laugh. So predicting Paris using machine learning. So the data science process, and we'll see this in the notebook later, is really, really important. The first thing you do before the machine sees any of the data, you split the data into 2 sets. And the proportion can vary, 2/3 or 80%, whatever. But you have a set of training data, and there's a function that splits it randomly for you. And you keep 1/3 of the data hidden from the model. You don't let it see the other third. You make not phrase that brilliantly. I haven't read that for a while. So you train your model to spot patterns in the 2/3, and then you see how accurate it is by making predictions on the hidden 1/3. You say, right, let's unlock, let's get that 1/3 of the test data, let's take it out of the safe, let's make predictions for whatever you're trying to, whatever variable, whatever field you're trying to predict. Will, based on all of the factors like how far it was, how expensive it was, based on all that, we'll make predictions for how friendly it was and stuff like that. And then you compare it with the actual value that you hid and see how good your model is. Then you can use, you've got a model that you can use for any conference. So I could say, right, codebar festival, how far is it? How far did I travel? Well, I traveled to my desk. So 0 travel time. It was free. So I've got data about the codebar festival. And in theory, with a large data set, if there were correlations, we could make predictions. And then understanding the limits, really, really important. Coming back to that, just having some statistical feel for, is it reasonable? What's the limits? Well, we only train the model on 2 data points, so it's not going to be very accurate. But it's amazing how many people expect, but I wanted 99% accuracy. Well, your data's rubbish. You're never going to get that. But it's still often worth making predictions, even though you know they're not going to be perfect. If you can, going back to the hospital analogy, if you can save 3 people's lives out of 1,000 or 1,000,000, it's worth doing. Statistics, really, really important, just to have a basic understanding of, is it reasonable? So linear regression, as I say, you have done it before. It's just scatter graphs, GCSE scatter graphs. You did it at school, but grown-ups have a horrible habit of renaming things to disempower people. Oh, I'm a professional. I do linear regression. You don't understand that. Well, actually, yes, you do. It's just GCSE scattergraphs with a bit more. Um, so, do you remember at school, you probably had to measure your hand span and then compare it with your shoe size or something like that. So the theory is that people with big hands have big feet. Let's investigate. Let's draw a graph, see if that's true. And then someone didn't have time to measure how big their hand was. They came in late or whatever. We can predict how big their hand is based on based on their shoe size or whatever the other features were. So you can make a prediction. Let's go back to the conferences data set. I've just chosen two fields. I'm going to use the number of participants to predict the friendliness. And yeah, hands up, I made this up. And I handpicked the data just to make the point. So it won't be as neat as this in the real world, but hopefully you'll see. So you plot your data, 250 people, 4-star friendliness, 400 people, 5-star friendliness. So you plot all of your points and you draw your line of best fit. In this case, there's only two, so it goes straight between them. And then we want to predict, well, how good is our line of best fit? Let's see if we can predict the third one. So we've got the 2/3 for training, that's drawing the line of best fit. And then we're going to use the 1/3 of the data, which is only one, a conference with 300 participants. And we're going to use that as a conversion line. So 300 participants, and that looks like 4 1/3 stars. And if we check the actual value, I rated that conference as 4 stars. So not bad, pretty accurate. To the nearest whole number, yeah, it's accurate. But as I say, it's a tiny data set, and I handpicked that example to make the point. What we've done there is interpolation. Inter means between or within, and pole is the limits of something, like the North Pole and the South Pole, the limits of latitude. So we've made a prediction within the limits of the data we've got. The other type is extrapolation. It has a general meaning, but strictly speaking, it means doing something beyond going beyond the limits. So I'm going to show you now an example of making a prediction beyond the limits of the data we've got. So same steps, same data set, and I'm going to pick travel time, see if that can predict friendliness. So same steps to start with. We plot the data. We've only got 2 points, so get your rulers out and get the line so there's the same number of dots above and below, and it's never very accurate when you're at school. But yeah, the computer can draw an accurate line, and in this case, it's just a straight line between them. So we've got our line of best fit, and then we want to test it on the 1/3 of the data. So the 1/3, the travel time was 120. Oh, our data only went up to 11. So I'm going to have to redraw the axes, rescale it. And look what happens here. And yes, again, I've cooked the books. I've picked an example that shows this really exaggerated phenomenon. So we have to extend the line. We have to assume that relationship does carry on in a straight line, and then we can make a prediction. So 120 travel hours would be a -7 star friendliness. That doesn't sound like a code bar conference to me. -7 star friendliness. Um, I just noticed Sen said, yeah, it might be reasonable to think maybe there's a correlation. The more participants, the friendlier the conference. Yeah, you might think that. And then you test it. That's GCSE scatter graphs. That is entry level linear regression. We're using one feature to predict what we call the target feature. We're using one predictor to predict the target. And we've got lots of fields there, and we can combine them all, but we can't do that on paper. This is the hardest maths you're going to see, and I'm not going to dwell on it. We could do it in 3D. We could take two of those. We could have one of them on the green scale, one of them on the red scale, and we could predict the height. That's quite difficult to look at, even with software where you can click and drag it and wiggle it. You can get some idea of the perspective, but fundamentally, it's just not the right tool for the job. As humans, we need to be able to visualize something. The good news is computers don't have a visual model of the world like we do. They rely on maths. Let's just look at a little pattern because I'm a maths teacher. If we've got one predicting feature, we use one feature to predict our target. So 2D coordinates, that's GCSE scatter graphs. We could use two predicting features to predict one target. We need 3D coordinates for that. And by extension, if we're trying to use three features to predict the target, we're into 4D coordinates. And my head thinks, oh, I can kind of just about visualize 3D space with, oh, it's a big value there, it's down a little bit there, it's not very good there. I get the idea that there's probably a plane somewhere through that space, but I can't get my head around it. And then the data set I showed you with the 7 features I recorded about the conferences, we're into 8-dimensional coordinates, and my head just explodes trying to imagine any human being having any hope of interpreting 8 dimensions. So the computer doesn't do it like that. Computers don't have a mental model, a visual model of the world. We could do scatter graphs. We could apply, even in 2D, we could make an equation. So y equals mx plus c, GCSE maths again. We could work out what the gradient of the line of best fit and where it cuts the axis, and we could make a formula like that to predict it. In multiple dimensions, you would have a harder. I didn't want to show you and put anyone off. I didn't want to show you what how complicated the formula was, but there are clever mathematicians who've written all that for us, and we as data scientists, we trust that it works, and it does. So that's the theory. That's as complicated as it's going to go today. Excuse me. So that's the end of the slides. We're going to move online in a minute, and we're going to have a look at an example of a real linear regression model and see how it's coded in Python. And we're going to see how well we can predict demand for rental bikes. Right. There's lots and lots of places you can run machine learning models. The simplest one I've ever found is an online platform called Kaggle. Kaggle is um, a repository for data sets primarily. It also has a nice beginner friendly online platform where you can type your Python and you can run those machine learning models. Everything happens online. Um, you don't have to give it your credit card. I've tried AWS, Google Colab, and Microsoft Azure. I had to give them my credit card number, and Microsoft Azure took 40 quid off me. I think that's dangerous. Close my account, um, come back to it later. I've since discovered what I did. I left something existing. It wasn't running, but I'm very, very wary of giving anyone my credit card details just in case something happens in the background while I go on holiday. Uh, anyway, the standard environment for running this code is a Jupyter notebook. Bit of a crap name. I don't know why they chose Jupyter. I'm guessing the PY stands for Python. But anyway, Jupyter Notebook, it's the industry standard in the Python stack. So I'm leaving the URL there. So when you look at I'll ask him to email out the slide deck with the link there. But I'll paste that in. Oh, how do I think I'm going to have to come out of presentation mode. It's the end of the slideshow anyway, so I'll just come out of that and then I can copy that and put. Oh, someone beat me. How did that? I didn't know you could copy that from. Well done, Steph. Right. Oh, manually. Um, right. Does it work? Yes, excellent typing skills as well. Right. So I'd say we're moving over to the Kaggle platform. Right. So if you click the link that Steph kindly typed for us, um, that will take you. Excuse me. That will take you to this page, to my notebook page on Kaggle, which I've made public. Um, if you want, there's, I've tried to minimize tech things that can go wrong. The only thing you need to do if you want to run the code, you need to set up an account. Um, you can, very standard, you can do that two ways. You can either sign in with your Google account if you're happy with Google knowing that you looked at a data science notebook. I hate Google. I never give them data if I can help it. So I signed in with my email address. I tried that with a second email address yesterday, and it takes about 1 minute. So email address, type your password twice, and it will send you a code, and you open your email, type the code in, and you're ready to go. So we'll give people another minute. You don't need to set up the account. Feel free to sit back and just soak it up and enjoy it. You're not going to be typing code. I've been to too many workshops, one absolutely dreadful, where we had to install 4 pieces of software and 2 browser extensions. It sounded really exciting. I was going to code my own blockchain 10 years ago, and it was really exciting, but it was just way too complicated. So I don't want anyone to have that experience. This is an introduction. I've written the code already. We're going to go through it line by line. Oh dear. We'll go through it line by line. I'll explain what it does, and then we'll see what the output is. And that same data science process that we've seen, splitting the data, looking for patterns. And if you think back to the awesome model, we've got to scrub the data because some of it isn't suitable yet. We've got to get it in the right format for machine learning, for linear regression. So we've got to do a bit of data cleaning before we can actually train the model. Right, I've been waffling for a couple of minutes. I'm hoping most people have got to the stage where you've either signed in if you want to run the code yourself, or you're happy not to sign in and just sit back and watch my version. Right, so we're bang on schedule. I was hoping, yeah, leave an hour for the notebook. So this, yes. Right, I've split it into several sections. So the first thing you do in any Python project is you import some libraries. Libraries are written because they're not part of standard Python. They do specialist jobs. So there are thousands of Python libraries. I'm assuming many of you are Python beginners, but you know the basics. Maybe you did it at school, and that is enough for this workshop. Just to explain that Python libraries aren't part of standard Python, so we have to import them. We need to add them to the version of Python that we're going to use here. So the libraries we're going to use, pandas, short for panel data. Panel data kind of means 2 dimensions. Not a great word, but it's the standard format for manipulating 2-dimensional data. So rows and columns. We've got rows for each conference, each record, and we've got columns for each feature that we're measuring or rating. So that's the main tool we're going to be using for tidying up the data, getting it into the right format. Matplotlib .pyplot, that's a graphing library. So we're only going to scratch the surface with that. It's incredibly powerful. You can do a whole grid of scatter graphs, so you can compare the correlation between every single variable. Sorry, I'm just looking back. Sorry, I should have checked should have checked the chat. Right, Christy said a few minutes ago, can you use your own Jupyter notebook or use the one on the link? It would probably be simpler if you did it on Kaggle. You can, if you've run Jupyter notebooks before, you can copy and paste each of the cells into your own Jupyter notebook if you're running it on your own environment locally. That's absolutely fine. Sorry, I should have checked that. But yeah, I think it's easier just to do it together on the Kaggle platform. So matplotlib.pyplot, that's the graphing library we're going to use. And then sklearn, scikit-learn is um, a scientific data science library. We're not going to import the whole thing. We're just going to import linear regression, and that's as you've seen, that's going to draw the scatter graph for us and the line of best fit. sklearn, we're also going to import the train test split. That's going to randomly split the data for us. So we've got 2/3, or I think I chose 80% this time. We're going to use for training, and it's going to hide part of the data, and we're going to unlock that later and use it to see how accurate the model is. And then the final thing from sklearn, we're going to import a metric called R squared. R squared is just a metric for evaluating how good the predictions are. Oh dear, not done this much talking. I've not been in the classroom for over a year. Right, so first thing in nearly any project, unless you're doing it in very basic Python, you import the libraries you need. Sorry, I should have prepared this. I'm going to restart and clear everything so it looks exactly like yours is. And then I'm going to click on the cell with the code in, and on the right hand side, I'm going to click the arrow, the triangle, and I'm going to run it. So you get the, whatever you call it, that used to be an egg timer, the loading indicator, whatever you call it. It's not. It's normally much faster. I think I'm going to refresh my browser because something's gone to sleep. And I've got the Zoom thing over the top. Can I squeeze that to right? Oh no, I didn't mean that. Come back. Oh dear. I knew something would go wrong. It's not the end of the world. I think. Right. No. Can I get it full screen again? Okay. Oh. I'm going to move that onto my other screen for a moment while I refresh it and get it working again. Oh no, that was the data set. Tell you what, I'm going to close that. I'm going to click the link like you did. Where's the? I just need the chat now. Too many windows open. Where's the chat gone?
I sent it to you via Slack, if that helps.
Right, thank you. I'm there now. Right, so that's opened on my other screen. Let's minimize the chat and bring that back across. Oh, the chat's on top. I'm going to close the chat because I've got it open on my laptop next door. Here we go. Right, and I'm signed in and nothing's run. Right, okay. Thank you for your patience. It's not like a classroom. There would have been the screwed up paper on the back of my head at this point.
It's all good, don't worry.
Right, so let's click on the first cell. Oh, um, I'm just sorry. I've just remembered. I should have told you. You need to make a if you want to change the code. Um, you would need to download. You would need to make a copy of it. Can I just check in the chat? How many people have managed to run the first cell so far? Um, you get the loading thingy. Um, Francis, yes, top of the class. Well done. It does work. Francis, to did you need to make a copy of it? I wasn't sure. Steph, yes, it's just the play icon. So I'm not sure why mine doesn't work. That's oh, because my view of it should be different from yours because I'm logged in. I'm the owner of this, so I should just be able to run it. I'm going to click edit and see if that makes a difference. Oh, that looks more promising. Right, so I could that looks much more promising. So I clicked edit. If yours isn't working, maybe try clicking edit. Um, copy and edit, yes. I just clicked edit. Maybe that's different because I own the document. Um, anyway, maybe is anyone still struggling? Let me know in the chat if anyone can't, if anyone's not got the play button, the execute. No, it looks like you're all ahead of me. It's just Sir who can't work his own computer. Right, I think we're good now. Um, so let me say a bit about Jupyter notebooks before we go any further. So there are two types of cells. Normally, you might be used to typing all your code in one screen, one line after the other, and then you run it all. Jupyter notebooks, you could, in theory, type everything in one cell. I won't go into reasons now why it's good to split them up. You might want to. The basic reason is you might want to change something near the end and only rerun those cells after what you've changed. The one we're doing, it'll run in a second or two. It's not big data. If you're trying to resort the Facebook database, that's going to take a lot of computing power, and you don't want to have to restart the whole program when you've made one little change. So we split it up into cells. It helps make it more readable as well. So each of these cells, so all of the imports are in a cell and they're a code cell. You can see underneath we can add a cell, a code cell, or we can add a markdown cell. If anyone's not heard of markdown, It's just a very, very basic form of formatting. So you can do bold. Let me show you. We can add we can add a markdown cell. I can highlight the word and then I can make it bold. So you might have seen in WhatsApp. Oh dear. If so, some people put an asterisk either side of a word when they want to highlight something. That has its roots, I think, in Markdown. And Markdown is surprisingly powerful. You can, in some versions of Markdown, you can do tables. It's ridiculously cumbersome to do a table in Markdown, but if you just want to make something in bold or a basic bullet point, you can do that. So you can highlight and click, or let me just show you, you could type one full stop space and then the first bullet, and then when you click off that cell, let's click back here. Oh, did I add a, not sure why it's not rendered that in bold. And anyway, it's not a Markdown lesson. Markdown's, yeah, it's neat. I don't use it very often. So sometimes you might think, why isn't my code running? Oh, because it's the wrong type of cell. So you've added a Markdown cell. You maybe decide, oh, I don't want to write a comment after all. I'll use that for writing code. You have to remember to change the type of cell. Apart from that, I find Jupyter notebooks really, really easy. They're very beginner friendly. So the second section, loading the data. So I've got the data from Kaggle. As I say, Kaggle is a massive store of data sets, and you can just click on the plus up here to start a new project, and then you can add some data sets to your project. And it's surprisingly easy. I found it a lot easier than doing it on my local machine or AWS, Google, or Microsoft. So to load, oh, I didn't say about short nicknames, whatever you call them. So we import pandas as, I can't be bothered to no, better example, I can't be bothered to type matplotlib.pyplot dot whatever the function is. So I abbreviate that. I give it a nickname PLT. So pandas, the standard is you import it and you call it PD. So anywhere in the notebook, I can use PD dot something, and then I can refer to one of the functions in pandas. So PD here, it stands for pandas, and then dot read CSV. Well, that's just going to read a CSV file, comma separated values. It will import an Excel file. It's data, it's industry standard. It will import pretty much any format out there. The tricky bit was getting the right file path. So I had to do a bit of work underneath the bonnet to track down where it had put my data set that I'd just added to the project. I was hoping it would put them both in the same folder. It's a bit fiddly. It's probably good if you've got a big project, but for a beginner, that's one thing I did find a bit fiddly, but bear with it or ask ChatGPT. In the end, ChatGPT told me, oh, you want to import this thing, and then it's like File Explorer in Windows. And I just started off with the Kaggle folder. What's inside there? Oh, there's a file called input. There's a folder called input. Oh, let's not change that. So I changed into the input folder, had a look what was in there. Oh, there's a folder called datasets. Let's go in there and have a look. And eventually I got down to the folder where my actual data was. That's the fiddliest thing in the whole project for me. So don't worry about it. Oh, Grigori couldn't find the file. I think at this stage, if yours doesn't work, you're very welcome to just watch my version. You won't have the satisfaction of pressing the run button and seeing it run in your version, but it will be the same unless anyone wanted to try tweaking the code. So let's see if that works for me. So I'm going to click on that cell. Let's execute it. Oh, did I? Oh, sorry, I didn't execute the imports, so it won't run. So I don't know how to stop it, but I'm now going to go back up to the first one because I have to import pandas before I can use it. So the session's running. Right, I've got the numbers. I think I had. I'm just panicking. Sorry. So the numbers next to the cells there, they tell you the order in which the cell was executed. So it looked, yeah, that's got a number 2. That suggests to me that I had executed that. So I did all the imports, and then eventually that worked. It came up with a number 2. So I've run 3 cells so far. And I've re-imported everything, but it doesn't matter if I do that out of order. That won't affect anything. So we're going to use another bit of code you will use all the time in Jupyter Notebooks, the dot head, and that will just display the head, that by default, the first 5 rows of the data. If you want to see the first 10, you just put the number 10 in there, or if you only want to see the first 2, just to check something's there without taking up much space. Anyway, let's run that. And that was quick. So it has imported it, and it's shown us the head. So we can see the data now for the first time. It shows us what the fields are called, and what's stored in the first 5 records. So we'll 20 past. We'll have a very quick look at what fields there are. There's a timestamp, and do you remember in the conferences I said I could split that up into different things that were useful? So I split it up into year, day, and month. Timestamp here has got day. I don't know which way round that is. Is it American or British? And then a time. So there's date and a time. CNT is short for count. That's counting the number of bikes that were rented in that hour. So if you look at the timestamp, it goes from 0 hours, 1 o'clock, 2 o'clock, 3 o'clock. So they're hourly data, hourly records of how many bikes, 182 bikes were rented between midnight and midnight 59 on the 1st of, no, the 4th of January, or is it the 1st? Actually, they've put the year first, so 01 is probably the month. T1 and T2 are temperatures. T1 is the actual temperature. T2 is one of those, feels like, oh, it's actually 3 degrees, but because of the wind and humidity and whatever, it feels like 2 degrees. So very, very similar. We'll come back to that. Hum is humidity, percentage, wind speed, weather code. We could look it up. They've when you look at the data, there's nearly always a really helpful commentary explaining what the codes mean. So weather code 3 might mean rain or whatever. We can look it up to get some domain expertise. But we're a bit short of time, so we'll just accept that their code, that different types of weather have been given a code number 1, 2, 3, 4, and whoever it is here hasn't stored them as an integer because Jupyter is displaying them with a decimal point. Is holiday. Now that's a feature, that's a Boolean. So just catching up with have I missed anything in the chat? Right. So a Boolean could be true or false, and machine learning models need numbers. So we store false as 0. So is holiday 0? That's false. So the 4th of January 2015, it's false. It's not a holiday. So that whole day, oh, that's only the head. We could explore the data set, and there aren't many holidays, bank holidays or whatever. Is weekend. So it was a weekend because it's 1. And then the season has been given a code as well. So it looks like we can tell from the timestamp, it was the 4th of January, and they're calling that season 3. So not really meaningful numbers, it's just a code. We'll come back to that idea because numbers have to be meaningful if we're going to make a prediction from them. So that's the dot head. Will show us what's there. And we'll use that a few times just to make sure it's made the right change. Now, exploratory data analysis, EDA. This is where we get inspiration, I think Cassie said. We have a look at the data and get a feel for it. So the dot head, that helps us as well. You could say that's an example of exploratory data analysis, just looking at those and going through it, making sense of them. And then a couple of other methods we could apply. .info will list all the columns and tell us how many values are present, because often we have to deal with, oh, it didn't record the weather at that time. Fortunately, I've picked a data set where there's no missing data. That's a major headache for a real data scientist. What do you do with missing data? And that's more than a beginner's workshop. And then the other method we're going to look at is describe. And that gives us a more statistical overview of each column. So let's run, yes. Let's run that and see what it gives us. So .info will give us a list of all the columns. So there's 17,414 rows in the whole data set and 17,414 in each of the columns. So that's great. That tells us there's no missing data. And it tells us what data type they are. So only the count, what we're trying to predict, that's the only one that's been stored as an integer. Everything else has been stored as a float, a decimal. The dot describe, this is what it gives you. It tells you how many values there are, so very similar. And then it gives you some basic stats. So what's the mean number of bikes that were hired in any 1 hour in London in that sample period? So there's an average of 1,143 bikes hired, standard deviation, minimum, maximum, and the quartiles. So that gives us a feel for what the data looks like. Interesting to look at maximum and minimum, just so you know what you're dealing with. Exploratory data analysis. We're not going to do much graphing here. We'll do one example, and we're going to plot a scatter graph to see how T1, the temperature, correlates with our target count. So PLT is the library. We're going to use .scatter, and then we're going to give it data frame T1. We're going to pass in that column and data frame CNT. We're going to pass in those two columns, and we're going to label them temperature against bike rentals and .show. I can't imagine why you wouldn't want to show the points, but yeah, we're going to show them. So let's just run that. And possibly not as helpful as we might hope. I can kind of see there's a very weak positive correlation. So there's nothing, if I just, there's nothing in the top left or the bottom right. Actually not much. So there are better ways of doing this. That's a very basic scatter graph, but I think I can see there is some kind of positive correlation, but pretty weak. So temperature on its own is not going to be a very good predictor. I know that already. I'm not expecting brilliant results just from the temperature factor. Another way of comparing correlation, we can use .corr. So let's run that. And it tells us there's a 99% correlation between the actual temperature and the feels like temperature. So they're almost the same thing. Depending on how important it was, if I was trying to spot cancer, then there might be a tiny bit of difference that might possibly save one extra life. But at this point, it's a beginner's workshop. It's meaningless. We're not trying to, I'm not Transport for London or whoever runs the bike scheme. It's extra data that does almost the same thing. So I'm going to drop it. If you've got a big data set, there's a good reason for dropping it because it adds in extra computing power, which you have to pay for. So let's click there and let's drop that. And then, in place equals true. That just means permanently drop it. You can temporarily drop it and just explore what happens after that. But I'm confident for today, I just want to drop it. I'm not bothered about what it feels like. So data cleaning and preparation we're on to. We've cleaned the data. Yeah, the boundaries a bit blurred there. That was arguably, we explored the data and then we've cleaned the data by dropping that column. So maybe I could have put that in the next one down in section 4, data cleaning. Data cleaning and preparation, as I said, includes things like the big headache, what to do with missing data. Most data scientists will say, I spend nearly all my time cleaning data. It's boring, but actually it gets results. So turning complex fields like the timestamp, we can separate out individual numbers like what time of day. There might be a correlation between time of day. I would expect that to correlate quite highly. So 8 o'clock in the morning, everybody wants to hire a bike to cycle to work. That's my intuition. And then we explore and see if it's true. So we've got a complex field timestamp. We can convert that into individual fields, single numbers. We might not use them all. I'm not bothered about the minutes. I don't think that's going to be significant. My intuition is that at 5 to the hour, there's not a sudden rush or anything like that. Again, I could explore that and see if it's true, but let's move on. So the way we do that is Pandas has a built-in method called toDateTime. So we take the timestamp. Sorry, we take the timestamp here from the data frame. We pass it into Pandas method toDateTime, and we overwrite that with. Confuse myself. Anyway, the splitting happens on the second line. So dt, I think there's a typo in there, but we've got 25 minutes to go, so you get the idea. That's going to split. We're going to create in the data frame. We're going to create an extra column, df hour, which extracts the hour from the timestamp. That's fundamentally what's going on there. And I think, oh, bugger, yeah. I'm not going to try and fix that now. I'm just going to delete that and pretend it didn't happen, and hope everything else still runs. I might have to. This ran last night. That's bizarre. I might have to delete something if it's trying to use something that's not there because that cell didn't work. But that will be easy. And then to check, I'm going to use the dot columns again, and that's going to. So let's check what we've got. We've got the timestamp. No, it didn't. It didn't create the hour. That didn't work. So we would have seen another column header in there, hour, but that didn't work. And then when we've created the hour, because machine learning only works, well, because linear regression only works with numbers, meaningful numbers, something complex like timestamp, it can't cope with that. So we're going to drop that. Did that work? There's no number. Oh. Right, let's pretend that didn't happen. And then we check again, check that timestamp has gone. Oh, timestamp has gone, but we just didn't manage to extract the hour. Okay, this is looking like it might actually work. I might have to remove hour somewhere later. So as I said, regression only works with meaningful numbers. Um, I've chosen a data set where there are no missing values. Um, so if it's, what do I mean there? Ah, right. Sorry, categories. Right. Sorry, I'm on a low resolution screen, so I have to keep scrolling. Categories. We've got weather code. That may as well have been um, instead of one, it might have been the string RAIN to show it's raining. It doesn't matter. It's not a meaningful number. So if rain is one and sun is two, um, two is not double one. Sun is not meaningfully double rain in any way. It's just names of categories. So the number is meaningless. So what we need to do is convert them into booleans. So for each record where it is raining, um, we need to create a boolean yes, no, 1, 0 to store that with meaningful numbers 1 and 0 that the machine learning model can use. So I won't explain how it does that, but you can do it the long way. I did the first time, and it was quite helpful just to get my head around what was going on there. But there's a built-in method here, get dummies. So dummy variables are things like is raining, and that's true or false. And drop first, if we've got everything categorized, let's choose a simple example, left-handed or right-handed. Let's assume it's a perfect binary and nobody's in the middle. I know lots of things aren't real binary in the real world, but let's assume left-handed, right-handed. We don't need two variables to encode that knowledge. If we just say is left, if that's true, they're left-handed. If it's false, by default, it means they're whatever it's not. They're right-handed by default. So we don't need a Boolean for every category. One of them, if it's not the first lot, if it's not the first, it's not the second, and it's not the third, it must be the fourth. So we can save a bit there by dropping the first one. Doesn't matter which one you drop, the model will still work. So did I run that? I don't think so. Oh, I'm not sure why this isn't working. We'll carry on. We've only got a few minutes. Where there's not much code. There's only a few cells left, so I'll just talk you through it. And apologies that I did try this, the very same version last night, and it worked. So we would use .info, and that would show us. I'll run it anyway just to see, but it's not created. It's not created any booleans. Damn. But you get the idea. And then season has been encoded with numbers. I think we saw from the first one that January was coded as season 3 for some reason. So winter would be season 3. We don't know. It might be in the documentation. It might tell us what the code was. But yes, you can say if they're coded sequentially. So 1, 2, 3, 4 in time order. There is a bit of meaning in that, but there's no meaning in 4 is 4 times bigger than 1. So there's nothing meaningful in saying winter is 4 times, which way around are we? Winter is 4 times spring. They're not proportional in any way. So we would encode those and get some dummy variables again. And again, dot columns to check it has created them. And then we've got all of our data set in the right format, ready for the model. And we want to tell it which one we're trying to predict. So the count, the number of bikes, and which fields, which columns are going to be the predictors, all of the others. So we would use the dot column method. That's probably the neatest way. Oh, it won't. Oh God, even that's not working. Right, that would, we used that earlier. That just produces a list of the columns, and I would copy and paste it, and I would paste it in here. So X is, did oh no, I didn't do a markdown. So the predictors are in the set X. It's capital X because there's more than one of them. That's just a convention. So we make data frame, and all of those columns, which don't include CNT, the count, all of those, we call those the predictors. And then data frame count, that's the target we're going to predict. So we've just told, not told, we've told the model which one we're going to predict and which ones are going to be the predictors, which ones we're going to base the prediction on. Then we split the data set, and there's a built-in function in sklearn, train test split. Let's have a look at the syntax there. So you say the X, Y, so the two sets, so you're telling it we've got the two sets, the predictors and the target, and we're splitting it into the X training and the X test. And we're also splitting it into the Y train and the Y test. And the test size, I've done 0.2 here. You could do 1/3 for the test and 2/3 for the training. I'm not sure what the optimum is, but yeah, something around that. And random state, that's just if you want to repeat it, it randomly splits, but you can get it to randomly split the same way. It's pseudo-random. So without that, if we deleted the random state equals 42, if I got you all to run that without a random state the same, you'd all have completely different random selections in the two sets. So that's more for teaching, if you want everyone to, but sir, mine looks different than the person next to me. Then what you think of as the hard work, training the model, is actually a couple of lines of code. Everything happens in the background. The computer does all the hard work. This is where the machine learning actually happens. So we set up an instance of linear regression, and we call it model. So linear regression with brackets, that just, it's like a teacher saying, right, get your graph paper out, your ruler, what else did I say? Ruler and a sharp pencil, and write the title model. So that's just setting it up. And then the bit that actually does it, so the students plotting all the points and drawing the line of best fit, that's fitting the model. That's where, that is the linear regression. So we tell it, use all of those training features, all of those predictors in the train set, and predict the y values. So model.fit, that does all of the plotting and calculating where the straight line is through the middle of all the dots. And then we test the model. So we've got the model, we hope it works, we make some predictions. So we unlock the hidden data that we put away, so the machine has no idea, it's never seen these records before. It's a random selection. We get it to predict based on all of the factors, based on the weather, the time of day, how many bikes were hired in that hour, and then we check it against the actual values. So we make a set of predictions from the model based on all of the features, how windy it is, what the temperature is, time of day. We store those in predictions, and then we compare them with the Y test, that's the hidden data, the actual number of bikes that were hired. And then we use a function called R squared that compares and produces a score. And when I ran this last night, it came up with 30%. And to start with, I was a bit disappointed. I thought, but I wanted my model to be 90 something percent. I wanted it to be impressive. And then reality check. All we know is what's the temperature, what's the weather, and what's the time of day. And we know whether it's a holiday, bank holiday or not. That's probably not going to explain all the variation. How would you expect it to explain all the variation in the number of bikes that were hired? There'll be, let's go over to you in the chat. What other features, what other things, what other factors might be at play that could help us explain some more of the variation in the number of bikes? Area, I think the data we've got is for the whole of London. So yeah, that would be a really good idea if we could get more granular data about different areas of London. That would almost certainly add value. Time of day, yes, we should have extracted from the timestamp, the time of day. The model has already taken that into account. Oh, if the football's on, yeah, cultural things like that, absolutely. That would probably explain a lot. There'll be a lot of people glued to a screen. Weekend or weekday, I think there was already a variable, is weekend, so true or false. If there was a big event, yeah. So if there were thousands of people all spilling out of Wembley at the same time. Oh, broken bikes, brilliant. Yeah, if there was a sudden wave of vandalism, that would certainly explain it. Repeat customers, yeah, regular customers. I'm not sure exactly what sort of data you would need to collect, but yeah, knowing how many people are in the scheme already and and they have a personal routine of doing something like that. Yeah, so there's loads and loads of reasons why the data we've got only explains 30% of the variation. And depending on what your business problem is, if you are running the bike scheme, it might be worth putting more effort and resources into collecting data about when's the big football match on in what part of London. I'm sure they do. If there's 100,000 people coming out of Wembley at 6 o'clock, they probably are aware of that. This is just a small data set that someone else had collected and shared. So real world data science, it gets very, very complicated. And you can say, oh, yeah, I want this data, I want that data. It's expensive to collect. You have to balance, do I think it's worth paying £1,000 to analyze, to get someone to go through the football fixtures and type in manually what time the crowd is likely to come out of each football ground. So yeah, absolutely. Oh, right, we've got a few minutes to go. That's the end of the notebook. I'm really sorry. I promise you it did work before I went to bed. So I don't know what's happened. I saved a final version before, and I haven't touched it. So anyway, lots of people are still with us. I hope that's given you a flavour of data science. That was entry-level data science. It does get a lot harder, but I hope you can see you don't need to be a PhD mathematician to be able to use data science. If you want to do a PhD in maths, do a PhD in data science, and write some new libraries and make these predictions in a better way, yeah, you need to be pretty good at maths. So data science, there's lots and lots of ways you can take this forward. Kaggle, as well as having a huge repository of data sets for you to practice with, they run competitions. Lots of people find that useful on their CV. The classic data set, a bit too big for a workshop like today, is predicting who dies on the Titanic. Bit grim, but that's one of the classics. And every month or so, there'll be a new competition they launch. They also have courses online. I haven't explored the platform for a while, but I think Kaggle is one of the nicest environments, and you don't need to, as I say, you don't need to worry about leaving something running in the background, going on holiday, and then Microsoft has taken 40 quid out of your credit card. Yeah, make sure it's a work credit card if you're doing that for real. Right, lots of people still here. I'm flattered, thank you. Any quick questions? I'm not an expert on data science, but hopefully that's given you a flavour. I'll do my best to answer any specific questions.